Hey, welcome back, everybody. Savis Algebra 2, a little trigonometry here, lesson 7-5. We are taking a look at the cosecant graph. The cosecant graph. Remember when we talked about this in class, there was a reciprocal here with the cosecant reciprocal with the sine. And then when we looked at how to develop it, and then I'm just not going to go through all that again, but that was my sine graph, ends the period at 2 pi. Over here, that'll be a negative pi. Here's a pi halfway through the period on the right. And so my sine, and then when we looked at, well, what happens with the cosecant, the reciprocal, remember, it was hitting at all these maximum and minimum points of the sine. And so we are just supposed to be choosing which one matches that cosecant. So which one looks like that? Here's this y-axis is an asymptote there. So my y-axis should be an asymptote. So that one's out. This one's a possibility. The asymptote there. That's an asymptote. That's okay. Then this one's out. Okay, so that leaves me with, I've got this one piece up here to the right of my y-axis a little bit. This one's way too far over, so I'm thinking, yep, let's go right here. So looking at some of those features, and we could get into it more detail, but we did that in class, so I'll leave that out. Look for videos on developing the cosecant graph. If you need it, one of my favorite is math is power for you. All one word. The 4 is the number 4. Math is power for you. Cosecant graph would be a nice way to search. Is this function an odd function? Remember, for an odd function, for each x that you put in, or if you put in the opposite of x. So if I put in an x and I put in a negative x, so what that means is, like, if I go over here to this value, there's a low point, and I go to its opposite on the exact other side. For odd, for even, they come out to be equal. So they're symmetrical over the y-axis. For odd, the y is about opposite. So these do definitely appear to be the case. And what that means is that they're rotational symmetry around the origin. But yes, this is an odd function. Next question. Let me get that stuff off the screen here so I can see what we're talking about. Next question. Does the function obtain a relative minimum? Relative minimum, go back over here, at my pi's. So the minimum right here, and if we had another one, when we got over here, the relative minimum, and if we went up here, so we had another one. So this is happening right here. My pi is here, so this is happening at pi over 2's. So this would be like 5 pi over 2 over there. And this one over here would be negative 3 pi over 2. So is it happening on the whole pi's? No. That does not seem to be the case to me. So then, is the domain all real numbers except odd integer multiples of pi over 2? So what this is saying is, are my asymptotes at the pi is over 2? So pi over 2 being right down, no, that's not an asymptote. That's a minimum point on my graph, so no. And then D, are the equations of the vertical asymptotes at the pi over 2's. The vertical asymptotes, my vertical asymptotes, is that pi? No, that's, my vertical asymptotes are on the pi's. My vertical asymptotes for this are on the 0 y-axis. We're on here at the pi over here at the negative pi. So no, this said, was it on the pi over 2's? No. And then let's see. My last question, does the function have a period of 2 pi? It seems like that would be probably right. I mean, we use the sine graph to get it. So we'd have to, for example, go from here to here if we wanted one of these low parts and the high parts of the cosecant function. Or we could use, say, if you wanted to, you get the same answer, use from the y-axis over until you get through this one right here. That would show 0 to 2 pi. So yes, the period is 2 pi to get both parts of the graph. And so that's how I would think through that problem, and hopefully that helps. The only thing we didn't do again is if you needed to actually go through how do you develop the graph of the cosecant, again, I would look up my favorite site for teaching things like that. Math is Power for You. Math is Power for You and YouTube, all one word. The 4 is the number 4. And keep after it. Just don't give up. You can do this if you stick with it. Have a great day.